Hello everyone, myself Kirtana J studying in Sri Venkateshwara College of Engineering, Bangalore. Today, let us know about the memory, process and storage management in an operating system. Let's look onto the contents, introduction, process management, process state and process in memory, advantages and disadvantages of a process management and components of a process management, memory management, advantages and disadvantages of a memory management, storage management, types of storage management and conclusion. Let's look on to the introduction to the memory, storage and process management in an operating system. Memory, storage and process management are the critical components in modern operating systems. These functions ensure that the computer system is efficiently and effectively running, enabling the user to perform tasks quickly with minimal errors. Effective memory management ensures that the program have access to the memory they need to function properly. While storage management ensures that the data is stored securely and efficiently, process management involves scheduling the tasks so that they can be executed in the most effective way possibly. Let's move on to the process management in an operating system. Let's know what is process management. Process is the program under the execution is known as a process. It's one of the function of an operating system. Process needs resources to execute the given task. The resources such as CPU, memory and input-output devices, and these resources are given either to the process when it is created or allocated it while it's running. The program is a passive entity and the process is an active entity. A single-threaded process has one program counter specifying the next instruction to execute. The CPU executes one instruction of the process after another until the process completes. Further, at any time, one instruction at the most is executed on behalf of the process. Thus, multiple thread process has multiple program counter, each pointing to the next instruction to execute for a given thread. A process is a unit of work in a system. Such a system consists of a collection of processes, some of which are the operating system processes that those execute the system code and rest of which are the user processes that executes the user code. The operating system is responsible for the following activities in connection with the process management: scheduling the process and threads on the CPUs, creating and deleting both user and the system process, suspending and resuming the process, providing the mechanism for the process synchronization, providing the mechanism for the process communication. Process have various attributes: process state, program counter, and process hierarchy. Now let us know what is process state. Process state consists of 5 states that are new, ready, waiting, running, and terminated. So a process has 5 states. The states of the process is defined in the path by the current activity of that process. New, the process being created. Ready, the process has all the resources which it is needed to run. It is waiting to be assigned to a process. Running, instructions are being executed. Waiting, the process is waiting for some event to occur. Example, the process may be waiting for a keyboard or an input-output devices, etc. Terminate, the process has completely executed or it's completed its execution. Now let us know what is process in memory. The process in memory consists of 4 sections: stack section, heap section, data section, and text section. Stack section, the stack in the memory is used to store the local variables, function parameter, function return value, and return address. Heap, heap is used for dynamic memory allocation. The data section stores the global and the static variables. Text section compares the compiled program code. There is a gap between a stack and the heap where when the stack is full it grows downwards, when heap is full it grows upward. Moving on to the advantages of the process management, improved efficiency. Process management can help organizations identify the bottlenecks and inefficiencies in their process, allowing them to make changes to streamline workflows and increase productivity. Cost saving. By identifying and eliminating the waste and inefficiencies, process management can help organizations reduce the cost associated with their business operations. Improved quality. Process management can help the organization to improve the quality of their product and ensure or service by standardizing the process and reducing the errors. Increase customer satisfaction. By improving the efficiency and quality, process management can enhance the customer experience and increase satisfaction. Compliance and regulations. Process management can help the organization comply with regulatory requirements by ensuring that the processes are properly documented, controlled, and monitored. Disadvantages of the process management. Time and resource intensive. Implementing and maintaining the process management initiatives can be time consuming and require significant resource. Resistance to change. Some employees may resist changes to establish the process, which can slow down or hinder the implementation of the process management initiatives. Overemphasize on process. Overemphasizing on the process can lead to the lack of focus on customer needs and other important aspects of business operations. Risk of standardization. Standardization process too much can limit flexibility and creativity, potentially shifting innovation. Difficulty in measuring the results. Measuring the efficiency of a program management initiative, difficulty in results, making it challenging to determine their implement impact on the organizational performance. Let us know the components of the process management. The key components of the process management includes process mapping, process analysis, process redesign, process implementation, process monitoring, and control. The process mapping, creating a visual representation of the process to understand how the task flows, identify dependency, and uncover improvement opportunities. Process analysis, evaluating the process to identify the bottleneck, inefficiency, and area of improvements. Process redesign, making changes to existing process or creating a new one to optimize the workflow and enhance the performance. Process implementation, introducing the redesign process into the organization and ensuring the proper execution. Process monitoring and control, tracking the process performance, measuring the key metrics, and implementing the control mechanism to maintain the efficiency and effectiveness. Now let us move on to the memory management. The term memory can be defined as a collection of data in a specific format. It is used to store the instruction and process the data. The memory comprises a large array or a group of words or a byte, each with its own location. The primary process of a computer system is to execute the program. These programs, along with the information they access, should be in the main memory during the execution. The CPU fetches the instruction from a memory according to the value of the program counter. To achieve the degree of multiprogramming and proper utilization of the memory, memory management is important. Many memory management methods exist reflecting various approaches and the effectiveness of each algorithm depending on the situation. So this is a diagram of the memory management. Swap out and swapping are the two processes undertaken during the memory management process. If the program is stored in the secondary memory, then it is called as a program. If it is loaded to the main memory, then it is called as a process. Hence, the swap out and the swapping are used in the memory management. Now let us know what is memory management and why it is required. In a multi-programming computer, the operating system resides in the part of the memory and the rest is used by the multiple processes. This task of subdividing the memory among different processes is called memory management. Memory management is a method in the operating system to manage the operation between the main memory and disk during the execution. The main aim of the memory management is to achieve the efficient utilization of memory. Why memory management is required? Allocate and deallocate memory before and after the execution to keep the track of used memory space by process to minimize the fragmentation issue, to proper utilization of a main memory to maintain data integrity while executing of process. Now let us know some advantages and disadvantages of memory management. Advantages of a memory management. It is a simple management approach. Disadvantage of a memory management. It does not support a multi-programming. Memory is wasted. Moving on to storage management. Firstly, let us know storage device hierarchy. Firstly, register, cache, main memory, electric disk, magnetic disk, optical disk, magnetic tapes. Let us know what is storage management. A storage management is defined as it refers to a management of the data stored equipments that are used to store the user or the computer generated data. Hence, it is a tool or a set of processes used by an administration to keep your data and storage equipment safe. Storage management is a process for user to optimize the safe use of a storage device and to protect the integrity of a data for any media on which it resides, and the category of storage management is generally contains the different types of subcategories covering the aspects such as security, visualization and more, as well as the different types of provisioning or automating, which is generally made up of entire storage management software market. Let us know what are the types of storage management. There are two types of storage management: file system management and mass storage management. Let us move on to the file system management. File management is one of the most visible, convenient for the users. The operating system provides a uniform, logical view of a information storage. Computer can store the information on several different types of physical media. Magnetic tape, optical disk and magnetic disk are the most common media. Each of these medias have their own characteristics and physical organizations. The diagram of a file system management. Now let us know the responsibilities of an operating system in file system management. Creating and deleting a file and directories, manipulate the file and directories, mapping files onto the secondary storage, backup files on stable storage media. Now let us move on to the mass storage management. As main memory is too small to accommodate all the data and programs, and because the data that it holds are lost when the power is lost, the computer system must provide secondary storage to back up the main memory. Most modern computer system uses the disk as peripheral online storage media for both program and the data. Most program includes compilers, assemblers, word processors, and formatters. These are stored on the disk until loaded into a main memory and then uses the disk as both the source and the destinations of their processors. This is a diagram to represent the mass storage management. The mass storage management used here is local file system, which is connected to a file server known as a network file system, which is connected to a Ethernet, which is connected to a client. Now let us know what are the responsibilities of an operating system in a disk management: free space management, storage allocation, disk scheduling. Moving on to the conclusion, effective memory, storage, and process management are the crucial components of a well-functioning operating system. Memory management involves allocating and deallocating the memory to ensure the efficient use of a resource. Virtual memories allows for more efficient in-use of a physical memory by temporarily transferring the data to a disk. Storage management involves managing the disk space and choosing the best allocation techniques for a given situation. Process management involves scheduling the process to ensure the fair allocation of a resource and maximize the system process. Overall, these concepts are essential to smooth operations of an operating system, and understanding them is the key to developing efficient and reliable software. By implementing efficient memory storage and process management techniques, developers can create a faster, more stable system that provides a better use experience. This is all about the memory storage and process management in an operating system, and thank you for watching.